Welcome. Welcome to part 7, I think we are now. Yes, part 7 of our little CNC build. So last time we actually did the first cuts and that worked out quite well. One second, I see one thing that's wrong with my camera. Let me quickly fix that. Here we go. So, that still doesn't do it. Okay. So last time we basically made the first cuts, and today we are hopefully finishing up the enclosure because, like, I already noticed, like, from the first cuts we made in last stream, plus like a little bit I did later. Grab that. Can I? Does it fit through here? Yes. So what I did so far is I made a little bit of a test cut here. So I just like surfaced this MDF, which created tons of dirt, like absolute tons of dirt. And that was basically the only thing I cut without the enclosure. I was like, nope, this will not work. A little bit of an oopsie here. So one time I forgot to set 0. I'm an amateur, so I need to learn a little bit. But yeah, in the end, what I did is like I designed this in Fusion. For some reason, I also forgot to select this one cut here. But I made a grid here and like a hole pattern. The holes also go through. The idea was basically this kind of like a trial for the spoil board I want to make later. So basically, the idea is to have this raster of like I think this 2.5 centimeters, just like to help me align stuff. And then these, you see like the opposite side here, so they have a little bit of like a pocket here. And I will just have like M6 inserts from the bottom so I can mount stuff to these holes. That's kind of like my idea. That was just like to play around and it worked quite good. The holes took forever because like I messed up some settings in Fusion, but like overall like it worked. And also like the grid with the V-bit carve with the carve V-bit worked quite well. So yeah, this is kind of like what I did like 4 weeks ago before I went on vacation. That's pretty much what I did so far. But yeah, it creates tons of dust, and like this is my living room, and I thought like if I have the vacuum cleaner next to it, it's maybe okay, but it was not. So this is where this little thing comes in. So this is one of the largest things I ever had on stream here. So we need to see how we do it with the camera. But this is an enclosure I designed in Fusion, and I still had these like plywood sheets flying around that I actually got for free, which is quite a nice deal. They have some weird markings like this arrow on the inside, but oh, like there's this hole here, and there's the second hole in the bottom back. But besides that, these are very nice plywood sheets. I got it for free, and I was like, this is perfect to use here. So I designed it in Fusion. I cut the plywood, and I also shaped this acrylic glass. And I think from the camera angle you have now, it looks perfect, but it definitely is not because it cracked. It cracked here quite bad while I was bending it. Also, here's a little bit of a crack. So I take this one as like prototype piece, and when everything is done, I will do a second one of these acrylic sheets. The main problem I had here, I think, is I used a teeny tiny heat gun, and there was just not enough heat to like properly like melt the acrylic glass evenly. So next time I have to use a bigger heat gun. So I think it was just the main issue. But yeah, this cracked quite bad here. And here, this crack happened. I bent that because like I wanted to validate that I can bend the acrylic like this before I cut the wood in these like funky shapes and all the extrusions, or I cut the extrusions to size to have the bend here. So I did that first, and then I was kicking around the apartment for like a long time. And one time I just picked it up the wrong way, and then like it cracked here. It's relatively thin. It's 2 millimeters only. But yeah, main goal for this is just to keep dust in, so 2 millimeters is perfectly fine. Yeah, then again, like this is a bit tricky to show because it is so big. But on the back here, we have little like gas pistons. They connect here, and then basically like if they're connected right now, they're not. They also hold this this top open, and yeah, the rest is all 3D printed. So it's a 3D printed hinges back here. So these are 3D printed. Then the corner bracket here, this is 3D printed. It just connects with a screw into the extrusion. And then what I installed only on one side, because I also wanted to work a little bit on stream on this enclosure. Now I have to hold it for a second. Are these things here? These are all printed. And then what I already fitted in here, you see it here, there are basically LED channels. I just ordered proper LED channels and designed the parts to fit them. So it's just a normal LED channel in black. I wanted them because of the diffuser, because the CNC creates a lot of dirt. And like this will just keep the electronics clean from any dirt. That was just the main goal, or like main reason why I wanted to have proper of these LED channels here. So this side I already installed just to validate that everything fits. And what I want to do now is basically install the other side. There's also here something we need to install. This was on stream already last time. This little breakout board where we connect the electronics box. And then inside we have our like breakout boards that we also saw on stream before. And that just fits in here. It fits very well. And then the other thing, we have this hole here. This is a pass through for two things. So there's this printed part that goes in here. And this is where I connect the vacuum cleaner. And there's a little cutout here on the bottom where we can pass through the cable of the router. So that's also something we need to install quickly. So that's part one, it's just like finishing up this case. I will not install the LED strips yet. That's for next stream, I think. For now, I just want to get the enclosure working that I can use the CNC. And then the second part is we need to clean up the cable, the wiring a little bit on the CNC. And then depending on how long this all takes, I have not really any idea how long it will take. We also need to finish up the electronics box because the tie is not properly mounted yet. We don't have a door yet. We don't have fans. So there's some stuff here and there to do. But yeah, I would say let's just start with enclosure. So we will just install this like strip here that the door properly sits on there. And then one thing, but it's also for later, like later being next stream, I still need like a little like a clip here on the bottom, like something here, like the Voron clicky clacky door hinge or something, to clamp that shut, because like the gas springs are a tiny bit too strong. So it kind of hovers a little bit and doesn't really fully seat. So I need to I need to help that a little bit. Okay. Let's just flip it over. And then my calculation was that I can just like swing the door open over my laptop. I hope this holds. And then my idea was we can kind of work here. You should see everything I do. And I have actually quite okay access. But yeah, this is definitely the biggest thing I ever had on stream. So that's a bit hard to maneuver. Yeah, and this also fits nice. So by the way, like these cutouts, what I do is I 3D print a template. So the template is basically like a strip just around that. And then I use double-sided tape to tape this onto the wood. And then I just use a jigsaw to cut the rough shape. And then I use handheld router with a flush cut bit to trace basically shape. I did the same for the hole here. That works really well. That's like one of my favorite tricks with a 3D printer while woodworking. I'm by no means a woodworking expert. I can build a box, but that's about it. Oh yeah, and these are just hold together like this is all like glued up. And I used dowels just to align everything properly. And I also used 3D printed drill templates for dowels that I'm sure that when I drill the holes for dowels that they align. Like I have zero skills, so I basically do everything with 3D printer and do templates. So I used the dowel, like glue to hold it, dowels basically to align all the things together. And then I used pocket screws here and on the other side to just pull the glue together until it's dry. And I think it's quite stable. My main concern is a bit that the CNC is quite heavy, so there's some weight in here. My main concern is that these two are not connected, so there's kind of like a weak spot. I think it's fine. But yeah, there might be something I want to reinforce with a little bracket here and here. But yeah, solid. Cool. Let's quickly look at the fusion. Just that we have a goal in mind, what we want to achieve. So this is the fusion I made for that. With the hinge. And basically we need to place now this half of the, actually hide that lid, this half. So I totally forgot what the distance here is. So that's 24.5. It's very specific. Let's most likely we'll round it to 24. So it's just like a little slider. I can now use it here to align that. Let me quickly fetch the parts. So these are like printed in segments because like my printer isn't that big. And I have little numbers on the back just to help me identify them. So that's 1, 2. And then I have a little, like, I designed a little dovetail here just so they can clip together. I wonder if I used glue there. No, I didn't. We can just use this to properly make sure everything has the correct distance. Okay. I think it's the first time we do woodworking. Let me just randomly start with this one here. Just trying to hit the center roughly of this hole. Oh, the screw is quite short, making it a bit tricky. Okay, that mostly locks this in place already here. No, it's like paying attention to its like massive swinging door back there. Okay, so let's see if we can. This is a tricky one to screw. So I'll try to hold this here in place and just screw this one here first. Okay. There's the second one here. And then only the little end pieces are left. Let's see. Oh, yeah. Should have checked before. The screw would be like screws would be like 1 centimeter longer. That would help a lot. Okay. And then there's one last one here, which I'm not sure if I can actually reach that because of the gas piston here. Let's see if I can. Should just about work. Okay. That is in. Then next step would be, so we have these LED strips here. Let me quickly snap off this connector here. I just use some random cables, and I figured it would be way easier to pass them through before we install it. And this should pretty much fit exactly. And I have a second one. It should be here. I think I do have. Yeah. Just to clean this up, this is the diffuser for the top. And just that I don't lose it or like damage it, let's just quickly put this in. Okay. Then let's finish everything that we have to have the case laying down like this here. Do I have the correct chat connected? No, I don't have the correct chat connected. Ha! I was already wondering. Welcome, everyone. What happened here? 1 second. I was already wondering because like quite a bunch of people are watching, but nobody was chatting. Right. So, welcome. Let me quickly read up. Hi, Steve. Welcome. Hi, John Doe. Hi, Mr. Desai. IP6567 LED strips. Actually, I think the ones I have are the things I had the LED strips. I don't think like these are not IP rated. Of course, they're completely bare, but you can buy them as IP67. But yeah, these were like pretty cheap because I just could pick them up at my hardware store across the street. I think I paid like 15 euros for them, and I had the LD strip. So, and this gives nice light. The main goal for this machine is CNC a lot of magnets. Can I CNC machine magnets? I never thought of that. Hi, the Rush, welcome as well. Hi, the Patsimir, and happy Friday to you too. Yes, the chat is broken. I don't know, like, I think I must have copied the wrong URL because I definitely updated the URL for the chat before the stream. I must have copied the wrong one somehow. No clue what happened there, but hey. Okay, but speaking of magnets, we need some magnets here, which will hold on the cover for this thing. So I would quickly glue them in, and then we have 4 screws to hold this here. And this one also needs 4 screws. We need to do it later though, because we have to pass through the cable first, because before we can put this in. So let's just start with super glue and magnets. No magnets here. Lots of magnets here. Okay. It's very nice how well this fits. Like it fits really good. Oh, this hole looks like it might not fit. It warped a little bit here in the corner. Yeah, this controller doesn't fit. The magnets here doesn't fit. Oh. So this one is a dot. I don't think we will make that fit. This one might also be a bit tight, but we will maneuver it in. I mean, no reason to have that many magnets anyways, to be honest. So if we miss one. Also will not fit. Oh, it does fit. This one is 2D shaped. I don't want to force this one. That might crack the part. But basically, what happened here, I just see it now. It's basically there's an overhang here around this part, and this corner warped up from the overhang for whatever reason. Let me also. There's the cover part that goes over that to try and close that. Let's also quickly put the magnets in here. Then we are done with magnets. Okay, so this needs to go like this, and I need to flip this one over. Okay. Magnets. Two. I need one more here. And one more here. The cable pass-through will cause issues, I think, if you want to be able to use the router of the CNC. So you will unscrew the pass-through a bunch of times. Yeah, that's the thing. Like the pass-through, I have to unscrew. That's the only downside. I will not use the router regularly. Wait, did I not do it right? 1 second. No, I did it the wrong side. So yes, I have to unscrew it every time. But I don't foresee using the router a lot of times. Like if I use it more than once a year, I will buy a second router. So this is more like I want to have the option to use the router. I don't plan on using the router a lot. If it's becoming a problem, I can also convert this into like like if the screw holes here are like where's the camera worn out. I can also drill the holes here and put magnets in. That this is a magnet snap as well. I love magnets. So that's also an option I thought about. So if I have to do this a lot, I will add like a small adapter plate here with a magnet. Okay, let's fix this in place. Perfect. Like this just holds most of the dirt out. Like there's still like some gap here. Maybe that's actually not the worst idea to like redesign this part a little bit. Add like a small adapter plate here with magnets. Then I just have to extend this out a tiny bit. Maybe that's not the worst idea, to be honest. Maybe I do that. It's actually like an excellent idea. Thank you, Mr. Design, for the inspiration. But yeah, this we do at the end. And then that means we can now flip it over. Let me think. I think we should close the lid. I don't fully trust the hinges here. And let me also quickly hook up. Show you, like here, you can hook up these gas pistons, gas springs. And now this hole's open. And when I close it, you see like it lifts a tiny bit, and that's why I need the door hinge there. Or not hinge, like the handle to close it properly. And another thing, you see like this, like it's bending like crazy. So like this is just a PLA print I did. Initially, I thought I can connect directly here, but then the angle was off, and like the pistons always pushed the lid open already from the bottom position. I think they're just a tiny bit too strong, but these are 80 newtons, and I struggled to find ones that were weaker than 80. The thing is, like, this lid is ultra light because it's just like this aluminum frame and a little bit of like thin acrylic sheet. One is too strong, one is too weak, two is too strong. So maybe I check with AliExpress if I find 60 or 40, because like it doesn't need a lot to hold it open. And then I can move the piston directly to the extrusion here. That was the idea initially, but now I needed to change the angle basically when it's closed, that this piston points a little bit downward. Catch. Thank you, Rush. I need a catch. Which I also thought about, could be magnets. That could be magnets, just a row of magnets here in the front. But yeah, so these are like not final. I actually thought about just, hey, I have a CNC. I can just mill these parts from aluminum, and then like it would be quite a cool like first project because it's a simple 2D cut. Yeah. Okay. Then I do my best to keep all the dust in here. So the parts are designed. Let me see if I can better angle for you. The parts are designed to have these like foam tape strips in here. Like on this side, I already have it. So let's just throw it in here. I just need to hit the corner. And the idea was that like most of the dust stays in. So I don't mind the noise so much. I don't think there's anything I can do about noise, but at least the dust should stay mostly in here. And I did only cut MDF so far, which, holy smokes, that was a dust experience. Yeah. Okay. And now we just do a second strip on the inside. And this case is quite heavy with the CNC inside. So I also was thinking about adding some sort of handle on the side. The problem is like this perfectly fits the like the shelf I store this in. So I don't have a lot of space left to write. So if I want to make a handle, I kind of have to cut it into the wood here, which I mean also works. Just need to come up with the design. Okay. Yeah, that's the thing. Like it just lifts off a little bit. But if I close it shut, like if I push it a little bit, like it's completely flush on the sides here. So I'm very happy. Only exception is here where basically the acrylic glass is broke. But it's quite nice. And then like it stays open. Cool. Yes, so this was mostly all the things I wanted to do on the case. I also still have to like plug these two holes I have here. There's this hole here, and that just like the this used to be a cabinet. So this was like a handle for like a drawer or something. Um, so these I have to plug. Otherwise all the dust escapes. But yeah, I think that's okay for the case so far. The LEDs I will do next stream because I'm not quite sure how long that takes. Oh, by the way, fun construction mistake. Oh, why is this a manual focus? Fun construction mistake. So this is a blind joint here, and the screw basically is along this X. So this is like the shorter one, this ends here. And what happened, and like I didn't think about that before, the gas piston was basically pulling on the extrusion here, so the blind joint just slipped out. So it was quite a shit thing. So now I added these like right bracket angles from the hardware store, and that fixes it. But basically without this, it just like shoots out the extrusion here. I think also now with acrylic glass, most likely will hold in place without these brackets, but I'll just leave them in for now. um, I don't think there's anything you can do about dust chips unless you are able to lower the pressure inside the enclosure about 50 to 100 millibar. Then ask me. Well, there will be the vacuum cleaner in here, right? The vacuum cleaner will be kind of like sucking air out. This should do something on the pressure, to be honest. Especially if the holes are plugged, there are no big gaps. So there should be like an under pressure in here, which should keep the dust in. Fingers crossed. But also like it really depends on the material, right? MDF is kind of like the worst case. Like MDF dust is hell. So I think if you machine something else than MDF, it's half as bad. Also, do you plan to mill steel? Is it able to? I don't think I can mill steel with this machine. I'm already having a little bit of doubts with aluminium because I don't like Ravenkeeper mills aluminium with this machine. But he has one linear rail on the x-axis, and I don't have that. And my router flexes a little bit up, or it can flex up. So I need to see how it behaves with aluminium. That's something I need to try out, but potentially we have to add like a linear rail to make the x-axis a little bit stiffer. But yeah, no steel for me. Cool. Yeah, let me move out of the way. Let's work on the CNC. Question is, where do I put this? Where do I put this? 1 second. Okay. So, here. It's a bit dirty now. It is a bit dirty, which is it's a good sign. But there's some learnings. So firstly, I decided to close off the V slots of the extrusions. And I got a little bit of these like filling thingies. So I just want to do like this 3 here, like this one, this one, this one on both sides. That's one thing. Then the second thing is I will use the same one here on the back because we still have these cables flying around. Including this one where I caught the edge of the table and I pulled it out luckily. But yeah, these should go in here because like if I move this around, it's like super annoying to have all this cable flopping around. So let's do that. And then what we also need to do is I printed the dust shoe. So this one we also need to install. And when we have these things, we can put the CNC in enclosure and can hook everything up. Let's just start with this. I hope this fits. I didn't try it yet. I just got it today in the mail. Yeah, that works really well. Maybe I should have used red one instead of black. Missed opportunity. That's a lot better to keep the machine somewhat clean. You should also maybe add it. Oh, like this is just like some random MDF sheet I had. But later this will be like I cut it perfectly fitting, and then I think this will be fine. Okay, then let's continue. Let me actually quickly. Some of the dust out. I don't think we need to do the ones on the outside. I just want to have the ones like that are directly next to the cutting area. And honestly, this one I also don't need to do because later the spoil board will be 20 millimeters tall, so the bottom one will be covered anyways. Oh, okay. Then where else shall we put some? I think these are the most important ones actually. Let's just put also here on the bottom one. Then I think we should add let's actually not do this on the bottom here. I also want to add it to the lid. A, it makes it heavier. And B, I think the lid also is like quite endangered with these things. So that's actually where we put the CNC in. Let's use a bit of that stuff on the lid as well. Because here, like the most important ones are now closed. And you also see like what happens, like the oil or like the grease of the motion system kind of caught also like some MDF dust. Don't think that's a drama so far, but also something to keep an eye on. Oh yeah, on the back we wanted to use it as well. So here we have two cables. And I just want to quickly use it here to press these cables in, that they don't fly around here constantly. Let's maybe do one cable per slot. A bit harder to press in with the cable underneath. Sure to not cut the cable, that would be not ideal. Where's the end? Okay, that holds the cables in here. And now we only have this contraption here, which is still like quite a mess. In my mind, this was cleaner, but this is how it ended up being. But we can shove all the cables in this like compartment here on the side, so you will kind of not see that. Okay, cool. Then, dust shoe. It's relatively straightforward. So basically, it's just this thing. This I 3D printed now. Later, this will be acrylic sheet, so you can actually see what the cutter is doing. You would need a CNC to cut it from acrylic though, and the CNC is not ready yet. So I just printed that for now. And we can later replace it with a acrylic sheet. So we have a couple of heat inserts on the top, and then also two on the side here, left, right. And then this basically just goes here. And then you can adjust this up and down a little bit, depending on what you need. So it's relatively simple. And then here we have a vacuum hose that is then connected. We are quite fast, so maybe if we put everything together, maybe we can try to cut the acrylic on stream. So, that's we also need heatset inserts. And quite a bunch of those. Oh, that's at 400 degrees for PLA is a bit hot. Bit hot. Lots of heatset inserts. Hmm. Doesn't 100% align. I think the hole here is not quite big enough because of the thing leaning forward. Yeah, it doesn't quite go in the position it needs to be. Like it's a little bit shifted to the front, but like, yeah, a millimeter, I would say. And I think the reason is that here this is not this is not at the same angle as the this like stud here. Now it fits. I should have gotten those in red. It would have looked a lot more cool. A lot cooler. Yeah. Just later acrylic, it will look really neat. Oh yeah. That was not printed with support here. A bit of filament droop downs. Do I need to? No. No reamer required. Okay. Yeah. Okay, so this should now go on here like this. So you can adjust it in the height. Maybe I forgot. You already said, but what's the name of this machine? Carla, I think. Yeah, Carla. I missed the opportunity to start a new naming convention for CNC machines. So everything needs to start with C. What kind of screw is this? This looks more than M3. This is an M4. Yes, this is an M4 screw. So let's find the fitting M4 screw for here. Wait. Ah, I was like, why is the lighting so off? It's because it's in the wrong mode. Yeah, I think M412 is quite a good thing. Do I have a 10? I don't have 10s. Let's use M410. Okay. I'm still so happy that I organized all my screws. Like I have like a bazillion of these boxes here. And these are all the different like M3, 4, 5 in socket heads, button head screw, flat head screw, in all lengths from 4 to 50. Some are empty. For example, I don't think I have, oh, I have some are empty. So I just basically organized it in all different sizes, so it's the same structure for all. Some are empty. That just means I have to buy some because my goal was a little bit to have at least like 10 of every size just available. If I do like streets, then it's nice to just have everything a little bit available, and we're not running out of screws suddenly. Hey, Helen, welcome. Carlo the Cutter, exactly. Let's put this on here. Oh no, this doesn't fit in between here. The M3 are not shorter, are they? No, they're even longer. Well, that seems to me like we need to do some modification here. So basically, this needs to fit in here, in between. Because I don't want to go for the other style nut here. Well, that means we need to do some tuning. Yeah. Now it fits, but of course not center. Means we need to take off quite a bit here of this part. Now it fits. Let's repeat that. And now this should fit. But it only fits in one orientation. That's important. It needs to face up. Acting like it's the first time I ever put a nut like this in. Yeah, this one is in the wrong orientation now. What did you miss? Well, we finished up the case, or like we completed the case as far as we can. We added like these strips in here to prevent chip buildup in the extrusions around the cutting area. We put this bad boy together, and now we are in the process of putting it on. I feel like 12s are better here. The 10s barely catch. Yeah, but the 12 also doesn't catch. Okay, that was not a problem. Nevertheless, we will swap for 12s. Let's investigate this little issue here. So why are you not? Oh, this is damaged. This doesn't work. Yeah, this is not working. This one works. Oh, That works better. A lot nicer than dig up screws like the 2.4 streams. Yeah, I know. That was one of the main reasons I did that. It's like, it's annoying for me, it's annoying to watch. And it's also like, if I build the kit, it's still somewhat okay because I know all the screws are in one place. But if I build something that I design myself, or that's not a kit like this like machine here, it's just like really annoying because you never have all the overview of all the screws you need in the end. Like there's still always some that like you didn't think of. Cool. Yeah, and this now I can slide up and down. Let me actually slide this down already because I know this is like way too high. Let's do something like this for now. Okay, cool. Then I would say this is so far so good. We do have this handy dandy vacuum hose here that will be connected here. I forgot to bring or to grab like a big zip tie to mount it here. So let me quickly check if we can just like string together something with the smaller zip ties I have here. Maybe they're actually long enough. Yeah. Let me do two. Those work. Let me take two more. And then this one here will go to the sides on the back here. So this will go here. And this is the second piece of this pass through. So basically I printed them in two parts. Oh, the other one is in the case. I print them in two parts because like they have like a flat side here in the middle, but like on both sides I have stuff sticking out. So I printed them just in two parts that I can print them flat. And then basically when you now screw them together, the screws will just pull them together. Let's also put two zip ties around here. Okay, so this goes over here. And then the cable of the router will take the same path. So I will actually, my thought was like to use these Velcro straps to put those together. I have more of those. I think we need one more. The cable goes to the bottom here. Yeah, one more we need. And then this connects it to the side, and the cable is like away from everything. This is relatively stiff together with the cable, so it also like kind of like doesn't get in the way of any of the mechanics. Let me quickly grab one more of these Velcros. I have them under the table. Ah, these Velcros, I have these refill spools, and every refill spool comes with 3 of these Velcros, and I actually love them. Like I use them for a lot of different things, so it's very, very handy. Okay, perfect. We just make sure that we have enough. I mean, this is the lowest position, right? If I can push this up, yeah, this still works. Yeah, this works in the whole range, so this is perfect. Would be nice to have these as quick release or thumb screws. Maybe thumb screw would be nice there. That you don't need a tool, but you can just like thumb screw it and like move it up and down. Okay, these are put back later. Okay, then I think we can marry the two halves together. Let me make sure to. How do I do that? Okay, this goes over there. Then I take the case. For some reason, my camera went to weird places. Okay, well, see, nice. You can even see it with the lid open. Let's make sure cables are not squeezed in. And oh, that's not like a bad angle. So this is a 50 millimeter hole, 60 millimeter hole for the plug fits through. And then this part, so that's what I meant like these two parts basically are both flat, so I can print them. And then they just come together like this. And the only thing is I hope this works here with the, I mean, this will just be pushed over a little bit. I think it will sort itself out. Okay, but before we do that, we have to put the cables back in here. So this is a bit of a pain, especially with the camera now here. But we have the 3 big plugs, and this kind of addition, we have these like 2. I kind of didn't think that quite through, but these 2 need to go to the Wagos down here. Let me do those 2 first. And also we need to make sure that the cables first go with the 3rd one here. Let me do this one first. This has 2 black markings. And 2 black markings go here. Then these two are a little bit combined, unfortunately, with the light pins. Let me get. Yeah, this I don't want to do like a lot. Whew. Let me try to use some tools. Here we go. With patience. Okay. This one has 1 stripe, so this one goes directly here. And this one has 2 stripes, 3 stripes. Yes, and goes here. And then the last 2. Whew, I need a break. This is quite hard with leaning over the router under the camera. The last 2 are the lights that need to go into the vagos, which not ideal planning, like how this works here. This was a lot easier before it was built into the case. I think the vagos should also become like a JST connector. I'm sorry if you don't see anything right now, but I see as much as you. Okay. That's quite something there. Let me make sure all the cables are kind of like in. And then we should be able to slide the perfect. And all the mess is gone. Okay. Then we still have to screw this one in. Let me first kind of mark the holes. Top two. Third time is the charm. Well, let's try this with the magnet thingy. Yeah, it's not magnetic anyways. And now the most fun screw. Maybe I should have not mounted the hose yet. That's it. Now the question. Does this work with the hinge down? It just works. So I think I may need to have this a little bit shorter, like this thing here. And just accept that like without the clip on the front, it will just go open. So like these gas pistons is still a little bit of work in progress. I didn't really allocate any space for them because I thought they would go directly to the extrusion here. So cool. Let's just move it a little bit and see what it does, right? Here's the control box. So that's still a little bit of a mess. So these fans are just loosely put here. That's something we still have to do. And then we have 3 Ethernet cables, which are not Ethernet per se, but RJ45 cables with a 24 gauge wire. And they all have to go in the correct spot. I will still make this one contraption to make this a bit easier with like labels on the cables. Okay. And then I need power. Cool. With all that, we should be able to move that. The getting X problem is why I was thinking of using a transparent tote upside down. with the lid under the machine. Huh. Not quite sure if I can imagine it. Upside down. With the lid under the machine. I mean, to be honest, like my idea is like you only have to do this if you have to move the machine in and out, which hopefully you don't have to do too much. So hopefully this is just the one time you know how to do that. But that being said, I need access to my laptop here. Okay. Cable here. Okay, then let's quickly head to the browser. And let's just see. Let's just home it. Oh, the dust shoe collided here. Oops. So that's something to pay attention to. I was just use a 0 all. And then we can move it like this. So this is kind of like the not quite most forward position, but pretty much as much as forward as it goes. So it's kind of like as much forward as goes, and like this is quite okay. Like actually, we could maybe shorten this this hose a little bit. This is as much as it goes here, exactly, because now it's at the end. But yeah, this I think is quite a good setup. And on the back, it's also quite okay. So if I don't use the extremes of the build area, this is 100% okay. And the only little concern I have is there. So I think this will just like push it down. Like this is not a big deal. Okay, shall we? Shall we connect the vacuum and just like see if it vacuums? Let's do that. Mm, So if I turn on the spindle,
He's crying for 1.5 hours.
1 second, I got a cat delivery.
He's crying for
Okay,
so
my cat was parked at my girlfriend's place, but seemingly he was not very happy. So now he has to endure the vacuum cleaner. Very bad timing. Let me quickly park my cat in the bedroom because otherwise I know him. He freaks out with the vacuum cleaner. So before I try that, let me quickly move him out. 1 second. Okay, so I had a ballistic tech. Making chips, I'm not sure because now the cat is here. The plan was that the cat is not here because I know he hates that. But seemingly he really enjoys it because now he walks next to the vacuum cleaner. Okay, let's just see. I'll quickly turn it on. Let me kind of move it in frame. Okay, I have to manage the cat again. Sorry. He's kind of like bombing my stream right now. 1 second. Sorry for that. Okay. Second attempt. There's a lot of suction here, so that's good. I waited, by the way, until the spindle was stopped. I'm not gonna lose my finger for that. But it's quite a lot of suction here, so that seems quite good. So let's maybe try. I don't want to cut too much, but like just a quick test. And what we could do, we could try to cut the little acrylic sheet for the dust shoe. Let me kind of like construct something here with some double-sided tape. I mean, technically we can also directly cut on this, to be honest. That's add this as intermediary layer. And here I have these acrylic sheets. Why I want to have this is just like I can, oh shit, like that's not 100% accurate anymore, right? Because like I moved that. I was like, I can align it on the grid, but like, of course I moved it. Well, roughly it should be okay. That's why I want to have this grid cut here, so that I can align parts like this on the grid. Okay. This should be fine. Then let's find the 0 point. And then we have to do some fusion action. That's a bit too much. Yeah, now that shoe could go down a little bit, but I think it's fine. So let's move that forward. And before we do that, let's actually also figure out which tool we need to use. Because I think these holes are relatively small. Please check. This is the Raven Special Ender CNC, where we have this dust shoe. And this is what we want to manufacture now. So let's create a new setup for this. Let me quickly check how big these sheets is. I think the sheets are 10 by 15. Yeah, 10 by 15. So let's just quickly set the fixed size. And the stock height is 2. So this is our stock. So we do need to make sure it's somewhat parallel, because otherwise we might not make it. Okay, but then it's relatively easy. We have a 2D contour. Before we do that, how big are these holes? 3.3. I don't have too many cutters yet. But I do have a 2mm one. So then this is kind of like what we need to use. Then the question is, where did I put the wrench? Here. First time I use this one. It's very tiny. It's good that we added the. Oh, if it's very tiny, we need to have the different. Wait, let me actually show you what I'm doing here. So there's a button here I can press, and then I can use the wrench to loosen the bit. There's now like the bit that fell out is here. So that's the 6mm bit, and that's the 2mm one. And for the 2mm, now it gets interesting. I do need a smaller collet, but I'm not sure where I put the collet. I think it's still in the. In the box of the router. I had it in my hands, and I didn't need it so far. Oh no, the small one is already in. I need this reducer thing. Ah, no, where's that? I hope I didn't lose that. So I need to have like a collet insert, and I know I have it, but I don't know where I put it. It's one of the parts that's flying around in these boxes here. It's one of these things. I put it in a spot where I wouldn't use it. Ah, yeah. I put it in a spot where I didn't lose it. I put it to the cutlers. It was in here the entire time. So basically, it's just like a small reducer to bring this to the correct diameter for the collet I have in here. Perfect. Okay. Mystery solved. This one can also go back. And I have 10 of these sheets, so we have 10 attempts. Okay, let's go back to Fusion. Don't forget to move the origins. Now you need to print the CNC with organizer. Yes, it's like one project after the other. Okay, so we want to have a 2D contour, and I think I can just select this and I will do it all in one go. The tool, we need to quickly look the tool up. So this is diameter 2, L12, this one. So the manufacturer of my cutters, they had like this Fusion library to download, which was very handy. I'm not going to move anything here. Okay, so it does this thing, but it doesn't cut through. So we have to quickly fix that. So the origin is on top of the material. And we want, yeah, here it says, you see the blue one. We want stock bottom. Simulate it quickly. Wait a minute. Yeah, it only goes to Z0, so it doesn't cut in the material. That's not what we want. Ah, this needs to be stock top. I'm still an amateur. And then this one we say 2.2. That like definitely cuts through, plus a little bit. Now it should. Yeah, now you also saw it. Now it interacts with the material here. And we will run this program once with a little bit Z above. Just make sure that we are staying within the bounds of that sheet. That looks pretty good. And this takes 1 minute 32 to manufacture. Do your clip configuration allow negative XY moves? Yes, they allow that. Okay, then we post-process. Wait, we do a post-process again. Post-process. We call this and now this generated a G-code file in my downloads folder. That's where I put that. And then we can just drop it here. And then we have the dust shoe top. What I will do now, we will basically set it to XY0. So that basically the tool is in the corner here of the sheet, but we will leave it a little bit up that we can see like what it's doing. And actually, we will also move the dust shoe all the way up that we have a little bit of visibility here. Okay. Let me move that down. Oh, now the dust shoe is in the way. Thumb screws would be really nice there. So I'm just trying to move it like somewhat close over the material that it's easy enough to like judge. Yeah, I don't think I can show you. I don't get that slow with the camera. Sorry. Okay, so I mean you don't see it, but this is now exactly over the corner. So in a web interface, I now 0x and 0y, and that means this is now the XY0. And what I can do now actually is I can move to X 150. And it's somewhat parallel. It's quite okay. I think we are okay. We will stay within the bounds of the sheet. So I will now move 10 millimeter. Let's move 3 millimeter up. And now I will set this as Z0. And now we can run the whole program without the cutter interacting with the material. I also will not turn on the spindle. So I will just run this. maybe I can show it from here a little bit. I will run this while hovering over the emergency. And it's completely off already. I will quickly emergency stop that. Did I set the correct origin? I don't think I set the correct origin. Yeah, I didn't move the origins exactly. Yes, this is where I thought the origins should be. No. Why is this why is Y going in the wrong direction? I am an amateur, as you can see. Okay, I select X, Y. That's the X-axis, and this is the Y-axis. No, what is it doing now? One second. Why is this so messed up? I don't understand right now why Y goes this direction. This should be my origin, but like in the other direction. I mean, I can't just put it here. But I don't know what it then does. Let's quickly post-process that. Upload that again to the web interface. Okay, upload it again. So I will just set 0 all. And I just want to quickly see in which direction it moves if I now print this. Now it cuts the first circle somewhat here. Now we just need to see that the second circle is on this side. It goes places. This is completely wrong. Why is the orientation wrong? So first it does the circle here. Then it does the small one. Yeah, it's just doing it mirrored. Oh, I need to still adjust the pause. Internet problem, nice to see you again. Welcome. But I don't understand now this setup issue here. So why is this the wrong way? It's also the wrong. Oh my god, I'm so retarded. Because this X and okay. Never mind me being stupid. Can we rotate that? No, Mr. Lisa, I mixed X and Y up. Wait, let me just. It doesn't let me turn it. Okay. Path of least resistance. I will quickly change the sheet here. Still struggling with stuff like that. Like I didn't do too many cuts yet. So we need to fit this like this. Let me quickly see. It's relatively parallel. Now we can try again. So let's quickly generate that. Looks good. And then we post process that. And we upload that. And now we need to find our 0 again. Okay, this is pretty much the front corner. Then I will go a fair bit up, and then we can like run the program now again. 0 all. Now it cuts the big circle. Now it cuts the small circle and then the contour. Okay, I would say let's send it. Only problem is I have to let the program finish quickly. Because if I pause it, it will try to again move to the pause position, and it's like completely off because the coordinate system is like on the workpiece and not the print area. I still have to fix that pause macro that it doesn't go like places. The only thing that concerns me a bit is like it will cut very close to the corner, and we don't support the material on the corner piece. So I think I will sneak in a bit more double-sided tape on the corners. I should have considered that. If I can get it under there. To be honest, we can also just try what happens. Okay. Let's see what happens. I don't think it will destroy anything. So let's almost done, and then we can start the spindle. We have to find the 0 position, of course, and then we can send it. Okay, let me find 0. That is 0 to me. So let me move that up a bit. The XY0 we still have. So now we can just turn the spindle on. It does cut. I think that's a success. Two things. Firstly, we forgot to add a strip in here on this extrusion, so there's not like again like stuff on extrusion. And secondly, it would have helped to move the dust shoe quite a bit down. But this kind of worked, so I'm very happy about this. It just like held on. More luck than skill. And this also worked. I'll peel them off later. Not a bad first attempt, I would say. The only thing is like this will have the same issue that this plate had. So we have to file down here a little bit. Thinking about now, we could have set a chamfer on the part. But this is a very nice, clean cut. Like, I'm very happy. I would say let's mount that. And that is definitely like a success. Does it count as wrap if the CNC machines its own parts? I will clean up later. Let's quickly get the dust shoe off. Ah. So the dust shoe, not perfect so far. I think I need to really move it down onto the workpiece. But I mean, it's a learning experience. And once I figured out, so not sure if everyone like caught that, but I completely messed up X and Y. Like for some reason, I thought Y would be this one. Friday evening for me. Does the spindle move badly around the Y-axis? I wouldn't say so, Mr. Design. No? No way, not a successful stream. It's not done yet. Don't jinx it, please. Minus one screw. Yeah, it has the same fitment issue that we already observed with the other part. So I have to do like a small modification. Now it should fit well. Well enough. Didn't see it on camera, but you were connected at the beginning of the stream. So for acrylic, no need for a rail. What do you mean by no need for a rail? I'm really happy about that. Like, this is the first functional part on the CNC. And it worked on first attempt. I mean, granted, it's a very simple part. It's only like a 2D contour. Ah, no need for concern. Yeah. I mean, acrylic is easy. It will be interesting. Ah, sorry, now I get it. No need for the linear rail for acrylic. Yeah, of course. So for acrylic, it's not a problem. MDF is not a problem. I'm only concerned about aluminum. Because if I move it here, like if I push up, just settle, I can, you see there's a bit of flex here. Like left, right is rock solid. It's just like up is like bit of flex. Here we go. Quickly move. Up. Yeah, I think I will try to get thumb screws for here because that would make it a lot easier. And then like next time you have to really move it just over the thing. Let's see if I can get this back on here. Yeah, I can. And now, like, I mean, this is makes it a lot easier because now you can just see what's happening like down here compared to the black one we had. This is really cool. Like, I'm really happy. Like, this is important step. So yeah, let's not jinx it or like let's not like challenge my luck. This is a successful stream. I'm very happy with that. Everything kind of went to plan. So I will call today. So we need at least one more stream then next week to finish up the electronics, do the lighting here. And I will think about having like automatic Z and stop finding thingy. And otherwise, next week I also want to machine the proper spoil board. So we can also machine that on stream maybe. So I think that's then quite a full stream again. There's so much force, even with aluminum. You can cut a lot slower. Should be okay. Yeah, this also like if I cut slow, it will be fine. Also, I can take shallow passes. Like I don't have to cut very deep. That will be fine. Like acrylic, you can cut 3 mm at a time, but with aluminum, you can cut 0.7 to 1 mm at a time. Yeah, exactly. Exactly. Will be fine. And then like at some point, maybe it's a nice upgrade to have the linear rail to just get a little bit more speed out of it. But these operations don't take too long. Like I'm most of the time will not do any like 3D things. So it will be relatively quick jobs like this one. And it doesn't matter if it's like a little bit slower or not. Cool. Okay. Well, then let's call today. Thank you everyone for tuning in. I'm super happy. I think this is like the most happy I am about the outcome of the stream for a long time. And yeah, enjoy the weekend. See you next week. Bye.